Hey everyone, this is the video for notes 4.3. So this set of notes, we're talking about square roots and how to use those to solve quadratic equations. We'll also wrap up with simplifying radicals. So basically, up until this point, we've started talking about solving quadratics and we've only talked about factoring. So this video is going to go through how to use a square root, because essentially in order to get rid of a square, to undo a square, you have to use a square root. Okay, so a couple of basic square roots of just numbers that I want to run through real quick. The square root of 49 is 7. The negative square root of 49, negative 7. Negative square root of 9, negative 3. Square root of 0, that's 0. Square root of 81 is 9. Square root of 100 is 10. Okay, so those are basics that you've probably learned in like upper elementary school or middle school, and you've probably seen forever. And if you're not familiar with them or you don't remember them, that's okay. That's what calculators are for. They can help you with that. All right, but ideally we want to use square roots whenever we're going through and solving for x. Okay, so the first few examples are semi-basic. Basically, in order to undo a square, you have to use a square root. But obviously, in a problem, there's might just be more than just an x squared or other numbers running around. You want to make sure that the x squared is by itself first before you square root stuff. So if I take a look at a, x squared equals 25, there's nothing else to move away from x. So I can go ahead right away and square root both sides. X equals. Now, I know that the square root of 25 is 5, but the question is it positive 5 or is it negative 5? Okay, well, think squares mean that you are multiplying something times itself, right? So 5 times 5, we know that's a positive 25. But negative 5 times negative 5, that's also positive 25, right? Well, in this instance, I don't know which 5 they used. I don't know if they used the positive or the negative. So in order to complete my answer, I list both. I can use the little plus or minus symbol, or if you want to write them separately, you can. It really doesn't matter to me. The main thing is understanding that there are two answers, just like with our factoring. There are two answers or two solutions, and these answers have to be, or well, there ends up being a positive number and a negative number. Okay, but that's basically what we're doing for each of these. So if I look at b, x squared equals 16. All right, there's nothing else around my x squared to get rid of. So if I go to undo the square, x equals positive and negative 4. The square root of 16 is 4. All right, for c, x squared equals 49. There's nothing else around my x squared, so I can square root to get rid of the square. And the square root of 49 is 7, so x equals positive and negative 7 would be my two final answers. Okay, so these are all pretty basic. There's not a whole lot going on with the x, and they're all perfect square numbers. So it's fairly simple to find the square roots of them. However, looking at the next set of examples, okay, for D, I have 5x squared minus 20 equals 0. Okay, I can't square off or square root things right away because, for one, 5 doesn't have a square root, 20 doesn't have a square root, at least as far as perfect squares go, right? I'm not going to get a nice whole number. But keep in mind, in order to square root, you have to be getting rid of just the square. Well, when I solve things, right, I have to work backwards through PEMDAS. So add or subtract first. That means I need to add 20 to both sides. That's going to leave me with 5x squared. 0 plus 20 is 20. I can then multiply or divide things. So divide by 5. 20 divided by 5 is 4. So now I end up with the x squared on its own. There's no other numbers running around. So in order to undo the square, I'm going to square root both sides. And the square root of 4 is 2. So positive and negative 2 would be my final answers. Okay, and those are the steps that we're going to have to remember to take as we go through our examples. Okay, for E, I have 3x squared minus 75 equals 0. Well, again, add or subtract first, so I'm going to add the 75 to the other side. 3x squared will equal 75. divide by 3. X squared equals 75 divided by 3 is 25. And then when I square root to cancel out the square, x equals positive and negative 5. There's my two solutions, my two answers. All right, so the rest of these, we're kind of practicing the same type of stuff. You maybe want to pause and try these on your own and then check your answers. I'm going to highly recommend you do that. But after you're done with that, then click, and I'm going to go ahead and go through these solutions now. So for F, the very first thing I would have to do, add 22 to both sides. 76 plus 22 should leave you with 98. Divide both sides by 2. 98 divided by 2 is 49. Okay, square root 49. And x equals positive and negative 7. Okay. Oh. I hate when this happens. Okay. Well, maybe I can talk through the rest of these while this is frozen and I'm trying to get it fixed. So for G, 2x squared minus 18 equals 32. When I go to simplify, there we go. Okay, if I go to simplify this, I need to add 18 to both sides. So 2x squared will equal 32 plus 18 should give me 50. Divide both sides by 2. X squared will equal 25. And when I square root those to cancel out the square, positive and negative 5 will be my final answers. Okay. And last but not least, so 4x squared plus 7 equals 23. Subtract the 7. 4x squared equals 23 minus 7 is 16. Gotta divide both sides by 4. X squared equals 4. Square root both sides. X equals positive and negative 2. There's my final answers. Okay, so all of those are pretty similar to each other, right? There's just 3 steps there that you have to do. You have to add or subtract something, you divide, and then you use your square root. I is a little bit different. Okay, if you take a look at I, you'll notice that there are parentheses here. Okay, whenever you're solving, you're trying to start your farthest away from the variable and work your way towards the variable. Okay, so in this instance, I can't start with the 3, even though it's being added. I can't start with it because it's inside the parentheses with the x. Okay, I got to move things that are farther away. Right now, the farthest thing away, or the thing outside the parentheses, is the square. Okay, so this is one time where I would actually have to use a square root first to cancel out that square and be able to solve. So I'm going to square root both sides. The square root and the square cancel out. All I have is x plus 3 left. When I square root 25, though, just like all my other problems I'm solving, I end up with a positive and negative 5. Okay, so here's one thing you have to be really conscientious about. I end up with this positive and negative number. Okay, 2 different numbers, 2 different answers. However, or I shouldn't say answers, I'm not quite done yet. I still have to subtract this 3 to the other side. Okay, I am not going to end up with a positive and negative version of the same number right now because I have to do the subtraction of 3 to both a positive 5 and a negative 5. So here's where I want to split these up. And I want to write out 2 separate equations. I have x plus 5, or x plus 3 equals 5, and x plus 3 equals a negative 5. Okay. You want to make sure that you separate them so that way when you solve correctly and you get the correct answers. So for the first one, I know I need to subtract 5 minus 3 is a positive 2. So x equals 2 is one solution. And the second equation, when I subtract 3, -5 minus 3, that becomes a -8. My second solution is -8. So there's my two solutions. But if you notice, they're not the positive and negative version of the same integer anymore. They're two completely different things. Just be really careful to look for that. Okay, we'll practice it more, but just be careful to look out for it. Okay, so that's one side of simplifying, or one side of solving, solving with square roots. The other thing I want to cover in this lesson is simplifying square roots. This is probably something you've done before, but not for a really long time, so I want to go over it and talk about it. It's pretty basic, though, once you take a look. So I'm going to go through this example in the little box here. It says simplify square root of 90. So all you have to do when you end up with numbers that aren't perfect squares, okay, we're not just going to type them into a calculator and get a decimal. That's not what our goal is. Our goal is to try to simplify the radical. Okay, in order to do that, we have to build a factor tree. Okay, so if I look at 90, they split it up into 9 and 10. The goal of factor trees is always to get down to prime numbers. Well, 9 I can break down a little further. They break it down into 3 and 3. And these 3s are prime numbers. So I stop there. Okay. The 10, they broke down into 5 and 2. 5 and 2 are also both prime numbers, so they stop there. Okay, so there are actually 4 prime factors, 3, 3, 5, and 2, that make up 90. Okay, the goal of simplifying, once you get to these prime factors, your goal is to see how many pairs you can pull out. Pairs get to go outside the radical, singles have to stay in. Okay, so think of it like a pair of shoes. You wear a pair of shoes outside, not a single shoe. That looks silly and could be dangerous, right? So singles have to stay inside. When you move a pair outside, or when you wear a pair outside, you wear them as one pair. You don't say or walk around saying, I'm wearing my 2 shoes today. That sounds ridiculous, okay? You don't say you say you're wearing your 2 shoes. You say you're wearing your pair of shoes, okay? So my pair is this pair of 3s, right? So those 3s move outside the radical. The 5 and the 2 are singles. They don't have a pair to match up with, okay, or a matching pair, right? You can't wear like a flip-flop and a snow boot together. That's not very practical. Okay, so the 5 and the 2 go back inside, but because they're factors, we multiply them back together and they become this 10 right here. Okay, so 3 radical 10 is the simplified version of the square root of 90, or radical 90. Okay, so I'm going to go through a couple of examples. There's lots of different ways you could come up with these solutions, or these simplifications. So if you choose different numbers when you're working through your factors, that's totally fine. The main goal is that the prime factors should always be the same. Okay, so the ending number should match up. All right, but I encourage you to kind of, again, pause the video and practice as much as you need to. I'm going to try to run through these kind of quickly because I did give a lot of examples, but here we go. So for 392, well, 392, lots of things can go into it, but I know for sure it's an even number. 2 will go into it. So 196 and 2 are factors. The 2 is a prime number, so I'm going to cut this one off here, but the 196, if I can break it down more, I can. I will also divide it by 2, so 2 and 98, going to 196. 98 can be broken down to 49 and 2, and then 49 can be broken down into 7 and 7 are primes. Okay, so I have 5 prime numbers here. I have 7, 7, 2, 2, and 2. I try to match together as many pairs as I can. Okay, well, it turns out I have a pair of 7s, I have a pair of 2s, and then I happen to have one single 2. Okay, so when I go to rewrite this, put my little radical, the single that's staying on the inside is this 2. So it goes right here. The pair of 7s and pair of 2s move outside, but they move as one pair, right? So 7 and 2 move to the outside. And because there's more than one number there, we have to multiply them back together. Remember, these are factors, so I can multiply them. 7 times 2 is going to leave me with 14. My radical 2. And there is my simplified version, 14 radical 2. Okay. Oh, oops. So radical 27, well, trying to get these on here, sorry. For radical 27, so I can break it down into 3 and 9. 3 is a prime number, so I can stop there, but 9 I can break down to 3 and 3. So when I pick out pairs, I have a pair of 3s. I have one single 3, so this pair gets to move outside the radical. The single has to stay inside, and the simplified version of radical 27 is 3 radical 3. All right. 75. Lots of ways I could break down 75. Let's say I break them down as 3 and 25. 3 is prime, but 25 can be broken down into 5 and 5. 5s are prime, so I have a pair of 5s, a single 3, 5, radical 3 is my simplified version. Okay, for 32. 32, lots of things go into 32. We can do 8 and 4. 8 can break down to 4 and 2. 2 is a prime, so I can leave it alone, but 4 can become 2 and 2, so therefore this 4 can also become 2 and 2. If I try to pick out my pairs, I have one pair of 2s, I have another pair of 2s, and I have a single 2. So because 2 2s move outside, 2 times 2 becomes 4, and then radical, my single 2 stays inside. Here's my simplified version for radical 2. All right, 210. If I break down 210, again, lots of different ways I could break it down. Let's say we do 21 and 10. Okay, 21 breaks down to 7 and 3, but those are primes. The 10 breaks down to 5 and 2, but those are primes. If I look at all my prime factors, 7, 3, 5, 2, all of those are singles, right? I don't have any pairs here. If you don't have any pairs, that means we're not going to be able to simplify anything. The most simplified version of the square root of 210 is the square root of 210, okay? We didn't know that before we checked, so we always have to check. But if it doesn't simplify, it doesn't simplify. That's okay. You just leave it. Last few examples here. Okay, 128. Let's break this down. Let's see here. I know 4 and 32 should go into 128. If I break down 4, it'll become 2 and 2. If I break down 32, it could be 8 and 4. 8 can become 4 and 2, 4, 2 and 2, and then this 4, 2 and 2. So I have 3 pairs. 1, 2, 3 pairs of 2s and 1 single 2. So keep in mind, if there's 3 pairs, that means 3 2s are moving outside, and we need 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is going to leave me with 8. Okay, be careful there. 2 times 2 times 2 is not 6, it's 8. And then the single 2 rests on the inside. Okay, 108. If I simplify 108, well, I know 108 is divisible at least by 2 because it's an even number. So 2 and 54 can work. 2 and 26 can work here. And then for 26, 2 and 13. Okay, so I have 1 pair of 2s. I have 2 singles. So 2 radical, and then the singles, remember, if there's more than 1, you have to multiply back together. So 2 times 13 will leave me with 26. 2 radical 26 there. For the 12, break down 12. It could be 3 and 4. 3 is prime, but 4 has a pair of 2s. Single 3, so 2 radical 3 is the simplified version of radical 12. Okay. And for 105, okay, so I know 5 goes into 105, and it should go in 21 times. 21 is divisible by 3 and 7, but all of these are prime numbers. That's not going to simplify. So therefore, radical 105 has to stay radical 105 because there's no simplified version. Okay. The very last things that I want to look at, and this is more or less going to help us later on in the semester, so I just want to kind of take a look at it now. Simplifying with variables. Okay, so believe it or not, if there is a coefficient, like a number, and then there's a variable underneath your radical, we can simplify both. As long as my screen will unfreeze. So I'm going to take a look first at the square root of 128 m squared. Okay, with this, I can treat the coefficient and the variable separately from each other. Okay, meaning I'm going to do my little factor tree for 128. I'm going to leave m squared alone for a second. So I factor 128. I know that 4 and 32 could go into 128. Factor 32 to 8 and 4. The 4s both become 2 and 2. 8 becomes 4 and 2, and 4 becomes 2 and 2. Okay, so lots of things going on there. When I square root the m squared, okay, so keep in mind a square root and a square undo each other, right? If I were to, even if I made a factor tree for m squared, it's just m times m. It's a pair of m's, right? So m is going to move outside of my radical. Okay, when I go through all my factors, I have 1, 2, 3 pairs here, and I have one single. The one single stays inside. The 3 pairs, remember 2 times 2 times 2 is 8, moves to the outside. 8m radical 2 is the simplified version. Okay, all of those stick together. Okay, I can do the same thing on the other side. So break down the 384. So 384, I know that's at least divisible by 2. That's going to be 192. 192 is also divisible by 2. So that's going to leave me with 96. 96 is divisible by 2. That's going to leave me with 48. 48 is, I'm going to try to use something a little bigger here. It's divisible by 4 and 12. 4 becomes 2 and 2. 12 becomes 4 and 3. And 4 becomes 2 and 2. So try to match as many pairs as you can. So I have 1, 2, 3 pairs of 2s. I also have a single 2 and a single 3. Okay, so remember, singles have to stay inside. If I have a 2 and a 3, multiply them back together. They're going to be 6. My r, remember, square root of r squared. This would just be r and r. So r moves to the outside. And for my pairs, I have 2, 2, and 2. Okay, same thing as with the 128. That becomes 8. So 8r radical 6 would be my final answer. Okay, that's the most simplified version I can get. All right, well, as always, if you have any questions, please let me know. This is the end of this lesson.